Today we will be talking about the shapes of molecules for AQA A-level chemistry. This topic has a lot of information which can be hard to remember, so hopefully this video will help consolidate the information and make it easier to remember. Molecules come in varying shapes and sizes, and you can predict these shapes by using something called the electron pair repulsion theory, which states that electrons in molecules exist in pairs and are found in space within the atom called orbitals. You can predict the shape of a simple molecule by using the ideas that each electron pair will repel all other electron pairs. Therefore, the electrons will be positioned around the nucleus as far apart as possible to minimize repulsion. Electrons may be shared or lone, and this is a factor in determining the shape of a molecule. We will now explain the different shapes that you need to know for the syllabus and show some examples. The first shape is linear, which has two electron pairs. The furthest apart the two electron pairs can get is 180 degrees, and therefore this is the bond angle in a linear molecule. This example is with beryllium chloride, but another is carbon dioxide. The next shape is trigonal planar, which has three electron pairs and therefore a bond angle of 120 degrees. Again, this is to allow the atoms to be as far apart as they can be to minimize repulsion within the molecule. This example is boron trifluoride. Tetrahedral is the next shape you need to know, and this has four electron pairs and a bond angle of 109.5 degrees. You may have noticed in the previous two molecules that overall the bond angles add up to 360 degrees. However, as this is a non-planar 3D molecule, the total of the bond angles can be greater than 360 degrees. And just to explain the diagrams, the wedge represents bonds coming out of the page and the dashed line represents bonds going into the page. This example is methane, but another is silicon tetrachloride. The next shape is trigonal bipyramidal. This has five electron pairs and bond angles of 90 degrees and 120 degrees. Again, this is a 3D molecule as shown by the wedge and dashed lines. This spreads out the atoms in the molecule and minimizes repulsion. This example is phosphorus pentachloride. We're now going to look at octahedral, which has six electron pairs and a bond angle of 90 degrees. The example here is sulfur hexafluoride. The previous shapes have all had only bonding pairs. However, some molecules have non-bonding pairs, also known as lone pairs. These lone pairs distort the shape of the molecule and reduce the bond angle by about 2 degrees per lone pair. This is because lone pairs repel more strongly than bonding pairs, so this causes them to be further apart. This results in two more shapes of molecules that you need to know, and we will look at these now. The first one you need to know is pyramidal, which includes three bonding pairs and one lone pair of electrons. It is based on the tetrahedral shape, hence why it is also a 3D molecule. However, due to the lone pair, the bond angle is reduced to around 107 degrees. A common example is ammonia. The next shape is bent. It contains two bonding pairs and two lone pairs of electrons, and like pyramidal, is based on a tetrahedral shape. Due to the two lone pairs of electrons, the bond angle is roughly 105 degrees. Water is a well-known example of a bent shape molecule. We now have a quick quiz to summarise everything from this video. All you have to do is fill in the gaps in the table, and you can either write this down or sit on your head. We'll give you 20 seconds and we'll then reveal the answers, but feel free to pause the video if you need more time. Okay, so the answers are the bond angle in a linear molecule is 180 degrees. The shape of the molecule with a bond angle of 120 degrees is trigonal planar, and 109.5 degrees is tetrahedral. Trigonal bipyramidal has a bond angle of 90 degrees and 120 degrees, and octahedral has a bond angle of 90 degrees. 107 degrees is in a pyramidal shape, and bent is around 104 or 105 degrees. We hope you have found this video helpful, and thank you for watching.